everyone, and welcome. Today we have a very special video. I'm here with someone whose career didn't just witness a technological revolution, he was one of its architects. He started at General Electric in 1960, just after they created the first man-made diamond, and went on to lead some of the most innovative companies in the diamond tool industry. He's an industry legend. He's also my father, Carl Roemmele. Dad, thanks for sitting with us. So your career is the story of this industry.
I was looking for a job, and I was walking down the street and saw a company building in Detroit on 8 Mile Road. To see the 𝗘𝗿𝗆 logo on the top of the doorway, building. GE's got to be an opportunity. Went in, asked them if there was any openings, and the personnel guy that I talked to said, yeah, probably. Fill all this paperwork out and we'll get back to you. And they did, and GE was starting the manufacture of diamond. That's actually how I got involved in the diamond tool industry as a technician at GE, evaluating some of the new diamond products that were being manufactured, or at least attempting to be manufactured back in the early days. My boss came one day and told me, "You're moving to Worthington, Ohio." And I said, "I am?" I said, "I haven't told my wife yet." And I did. I went from Detroit, which is where the processes were first developed, down to Worthington, Ohio, right outside of Columbus. From there, my time with GE over about 25 years continued to evolve into different positions, from an application testing technician to an application engineer to a diamond manufacturing engineer to the manager of recovery systems.
At what point in your career were you offered the sales position, and then how many years did you spend traveling the world?
I decided one day, I thought, been having a lot of fun. Maybe I'd like to try sales. My boss told me that I didn't have any experience in sales. And I said, "You're absolutely right. But how am I ever going to get it if you don't give me a chance?"
Good point.
So he did. He asked me one day, he said, "How would you like to be sales manager of the Pacific?" Pacific? You mean California? No, he said, "I mean the Pacific region. China, Japan, Korea, Taiwan, the Philippines, India, Australia, New Zealand, so on." Wow. That was, pardon me, that was overwhelming.
That's a lot.
That's a lot. And I did that for uh, about 4 years, almost 4 years. 𝗬𝗏𝗺𝗺𝗃, who was the general manager and my boss at the time, decided that he wanted to do some organizational changes to reach the marketplace a little bit more effectively. He created a new position called global or worldwide. He called it worldwide marketing manager. He asked me if I wanted the job, and I thought about it for a while and said, "I'll get back to you." I thought, well, I may as well give it a shot.
So in the middle of all that, as you were starting a family and starting this job, you decided to get a degree in electrical engineering. Is that correct?
Yes, that is ultimately correct. At first, I thought I'd want to be an architectural engineer, but I soon changed my mind when I saw how boring that was sometimes. So I decided to venture into electrical engineering, mainly because I didn't know anything about electrical engineering.
Mhm.
And I thought it was a way to learn something and make more money. And one of the senior vice presidents of GE at the time, at one time, asked me, "Why did you get your degree ultimately in electrical engineering? Why not go into chemical? Because GE is actually bigger in the chemical industry than in the electrical industry, believe it or not. And I said, well, it's mostly because I was looking for more money to support my family. And he says, you can make a hell of a lot more in the chemical industry. I'll never forget those words.
Yeah, yeah.
Anyway, so that's how I started in
After 10 years of night school.
oh, after 10 years of night
then
school.
you found out the chemicals.
That's a good point. Thank you. I kind of ignored that only because I'd like to.
Yeah.
But in any
A lot of
event,
work.
yeah, it was that was a long haul. You know, having a wife and 1, 2, 3, and then 4 children at home. She did a tremendous job replacing me because I was either at school or at work.
Yeah.
Going on 16, 18 hours a day. So it wasn't an awful lot of fun, but in any event, we got there.
Oh, it sounds like it wasn't an overnight success. I'm sure there were a lot of hurdles that you had to overcome. What were some of the hurdles that kind of stick out in your mind?
We found ourselves in the, I guess, enviable position of having outgrown our own usefulness. We had to start developing more, better crystals, larger crystals. That took the requirement to evolve a whole new technology of and expertise of diamond. But the only diamond tools we had at that time was a product called RVG, resinoid vitrified grinding, which was not used in the construction industry at all. It was really used in the tooling industry for grinding of tungsten carbide and super hard metals and the like. The next product process we looked at was how can we get into a broader market. The first of which was called MBG, metal bond grinding, and the next one was MBS, metal bond sawing. Metal bond grinding really focused mostly on the glass and ceramics industry and the light stone at that time. And MBS was really the start of getting into the heavy work, cutting concrete, asphalt, brick, block, tile, and so on and so forth. We did many tens of thousands of experiments on different machines and different blades, different drill bits at different speeds to find the right combination. We would also engineer opportunities in the marketplace. We'd create like some of the diamond. We created there are many of those products. Well, I don't know, maybe still do. Where we come up with a new product. Say, okay, guys, what do we do with it? It's a good product, we think. Where are we going to use it? Selling industrial, or as the industry wanted to call it, the natural industry wanted to call it, synthetic diamond. It's real diamond. It's not synthetic. It's real by every technical measurement. Man-made diamond was real. Diamond was real diamond by every scientific test. That's incredible. Remember there's 3 tests.
Yep.
And if it fails any one of them, it's not real.
Yeah.
People were very reluctant. Oh, they're not real diamonds. Damn it, they are real diamonds. But it took a lot of educating. Man, it was tough. When we moved down to Northern Ohio, we were having quality problems. I couldn't figure out why. And all we did was move from Detroit to Columbus, Ohio, 400 or 500 miles. That shouldn't have caused any problem. Well, lo and behold, I had this brainstorm one day, and we got to talking about moisture. And I said, if moisture, which is H2O, oxygen and oxygen, gets into that cell when it shouldn't be there, or unintentionally, it can have an adverse effect on the residual product, which is diamond, that comes out. And so what do we do about it? And I said, I want to go and buy a whole bunch of refrigerators and strip them of the cooling system. I don't need that. And I want to build desiccators into them. I want to pump air out of them. so that there was no moisture in them.
Mm-hmm.
Couldn't find enough of the GE refrigerators. This is GE company. So
Yeah.
I said, well, screw them. Buy Westinghouse. I don't care who you get. I just want refrigerators. Vice President of GE came through on a tour one day.
Yeah.
And I have a whole bank of non-GE refrigerators set up as desiccators.
Yeah.
He wanted to know what idiot authorized those to be purchased.
Yeah.
Did it work though?
Oh, yeah.
Yeah.
We solved the problem.
Yeah.
And it not only solved our problem, Detroit was also having a problem that they didn't even know of.
Yeah.
And once I sent some of our product up to the guys up in Detroit, which were still making diamond up there, but having troubles, but not as bad as ours.
Mm-hmm.
And I sent it up to them, and 𝗘𝗿𝗆𝗆𝗆 was one of the guys. He looked at the diamond and he said, where the hell did you make this stuff?
Yeah. Yeah.
And one of the technicians up there that I had sent it to up in Detroit said, Carl made it down in Ohio.
Mm-hmm.
So that's how we solved that problem. That was a multi-million-dollar problem.
Yeah.
That was big.
Incredible fix.
That was big. 𝗥𝗍𝗄𝗆 out of California, LA. There was one point in time when our company, we had a technological issue with some machines, and we're almost out of business because we couldn't produce the right kind of product. And 𝗏𝗏, who was the owner, he's dead now, was the owner of 𝗏𝗏. He made the product for us. Cooperation, even though we were competitors. And they were having metallurgical problems with their segments, both bonding the segment to the steel blade, but also internally within the segment itself. And so I had them, this was a long discussion going through, because, you got to remember, I came from an evolution of knowledge and not thinking back of what it was like before that.
Yeah.
So I'm asking the questions, and then they're saying some things to me, and all of a sudden they said, wait a minute, what kind of molds are you using for your segments? Well, we're using carbon molds, because of the induction heating. So what are you coating the molds with? We don't coat molds. Wait a minute. You're making diamond and powder, metal powders, inside of a mold that's all carbon.
That can't work.
That's not good for the diamonds, and it's not good for the steel or the matrix that you're using. Well, what do? We can't use steel, and so on. No, you can't. Graphite or carbon is fine, but coat it. And it was that simple. He said, what do you coat it with? I said, milk of magnesia. What? I said, you're crazy, milk of magnesia. I said, my molds don't have an upset stomach or anyway, that was the solution.
That's
You
incredible.
just take a paintbrush, and you make black white, and then you put your gizmos, all your parts in there, put the plunger in for pressing the segment and everything, put it in the furnace, melt it, smelt it, and so on and so forth. Problem solved. We came out of the bar after that. They couldn't wait to get, this is like, I don't know what time, midnight, 1 o'clock in the morning. I don't know, something like that. They couldn't wait to get back to their shops and go to work, trying this new
Milk of magnesia.
And the four of us walking out, and I turn around. Where the hell's Gary? Did we leave him inside? Which wouldn't have surprised me with Gary. We go back inside, look around, no Gary. And I said, wait a minute. When we were standing here, I caught out of the side of my eye, I thought I saw a car go by with people hanging out the windows and waving. And I thought I saw somebody getting in the car while it was moving. But it didn't register at that moment. It wasn't until I started thinking, you don't suppose Gary got in that car? Well, that's exactly what happened. He didn't show up until about 5 o'clock in the morning. Bob and Des were there. He said, "I'm going to kill that little SOB when I catch him. I'm going to kill him." We were worried like hell. He comes walking in, 3 sheets to the wind. Never forget that. He was fine. No problems. Nothing went wrong.
He was alive.
He was
Apparently, he
alive.
dove into the window.
Yeah, dove in the window of the car. He was a nut. This guy was a nut.
You mentioned the stone industry was a little bit different in Europe and Asia, and what were some of the differences that you saw early on in your career with the differences around the world?
Yeah, that's a good question. You have to go back to the start of how stone came into being. Stone was big in Europe. It was not big in the States at that time. Everything in Europe, historically, was made out of stone. Their technology was really centered around the stone production. So they always worked with stone. So they got to be very, very good at stone, even though they used to cut with a swing saw and water and sand, and eventually transitioned into gang saw blades and so on with diamond. The Americans didn't have a clue. We didn't use a lot of stone. We didn't build castles here. We built things out of wood, brick, block, and concrete and mortar, and so on, which tends to have a degree of permanence, but nothing like a castle.
Granite, yeah.
Like granite and marble.
Granite's not
Or,
going anywhere.
yeah.
Yeah.
The development of the stone market in the U.S. really started with the help of the Europeans, mostly the Europeans, some of the Asians. It was cheaper to make, to cut, grind, polish, and size the stone in Europe and ship it to the U.S. than it was to make it here.
Yeah.
Because the tools didn't exist, the machines didn't exist, the technology didn't exist. It really changed with the cooperation of other manufacturers and with the users, the guys that make the stone, that grind it and polish it and drill it and so on. And it was really a joint or cooperative effort. That was a whole evolutionary change. It didn't happen just at one time. It was new product after new product after new product, getting better and better and better.
You were also an innovator yourself, and we have here actually one of your patents. If you could tell us a little bit about.
Yeah, sure. Well, as I guess I couldn't let my engineering degree go to waste, even though a diamond saw blade is not an electrical product, and I was an electrical engineer.
Yeah.
I always I used to tell everybody that electrical engineers are the smartest engineers in the world, and I don't know if that's true or not, but I know I annoyed a number of mechanical engineers by saying that. One of the products that that became obvious that we needed to explore for development was to speed up sawing and drilling. And in order to speed up the sawing, the time to make a cut, you had to consider several things. The bond, that is the matrix that holds the diamond in place, which is a metallic-based system. The diamond itself, what size, what shape, what nuances in the diamond had to exist in order to tolerate the increased speed and heat during the sawing operation. And then the other thing was the mechanical layout of the diamond blade itself, because when you're cutting concrete, cutting asphalt, cutting stone, cutting brick or block or anything, there's an overburden, a slurry, if you will, that just like sawdust when you're cutting wood, and it builds up in the cutting operation. And that slurry, if it isn't excavated properly and quickly, will actually tend to erode the matrix that's holding the diamond in place, and the diamond blade wears out faster and doesn't cut as fast. So I said, well, it's a simple task, is just make the groove, the slot between the segments where the segments are either
Gullets?
brazed.
Is that what it's called? Gullets or
The
something?
gullets, yeah.
Yeah.
Some of the segments are laser welded onto the steel core. Some are brazed on. Today, they're almost all laser welded. So we did some development work on increasing the gap between segments, which would create more volume for the slurry to get into, to get thrown out and excavate the
And
cut.
that would speed up the cut.
It would speed up the cut and protect the blade better.
Yeah,
It was, and it was a roaring success. However, it was also incredibly noisy.
Mm.
The whistling and the cutting because of the increased gap, and users, especially in the highway construction market, especially, loved the blade. They tended not to use it eventually because of the noise level and the OSHA requirements for noise abatement and so on. If that was running in this building, you couldn't be in it. I mean, it would scream because of the rotational speed. And then once you started cutting, then it'd go up an octave or so.
And then in that, you helped develop the MDE 350 masonry saw, which we still
Oh
have in
yeah, the
our
MDE
warehouse
3.
that
Yeah,
we
that's right. That was developed in conjunction with. I forgot about that, but that was developed in conjunction with a company out of Taiwan that I knew very well. They already had a machine, but I said it wasn't adequate. Rather than take offense at that, they said, "Well, what do we have to do to improve it?" So we worked together and eventually came up. Mostly them came up with the things that the features that I wanted in the saw in the machine.
Interesting. Are there any other challenges that you faced?
Oh yeah, there were many others. We tried getting into concrete floor polishing, for example, for warehouses, cattle pens,
Anti-slip.
anti-slip, because it's quite expensive. If a cow slips and falls, breaks a leg, and then it has to be put down, they lose several $1,000s. So we had to figure out a way of increasing the toughness for the cattle to walk on without slipping. That was a very successful product. That was a combination of the development of the machine, which is a walk-behind machine, and the diamond tool itself, both of them. And we developed both. I remember one incident, I'm sorry, I'm digressing a little bit,
Go ahead.
but one incident I remember, 𝗘𝗿𝗆𝗺𝗺, who was one of the original developers of the diamond process, along with Herb Strong and Tracy Hall and so on. In the manufacturing process, it's very difficult to explain, but when these two compression cylinders come together, there's a ring around it, and it's compressing the carbon and nickel iron catalyst together to make diamond with heat and pressure and so on. But you have to insulate it somehow so that you don't escape the heat and the gases and everything. He and one of his guys that I was good friends with were working on manufacturing 𝗿𝗺𝗺𝗺𝗏, or we call it lava, which was a synthetic material, so that we didn't have to rely on foreign suppliers. Well, the thing that really sped the process up was when a tanker sunk on the way in the Pacific Ocean with a shipment of tens of thousands of tons of 𝗿𝗺𝗺𝗺𝗏 that was coming to us for our process.
Yeah.
We were out. That was scary.
Yeah.
I got to tell you,
Yeah.
it was scary.
Production stops.
Yeah, production almost stopped, but it wasn't perfect. We had a lot of problems, but it gave us time to evolve the whole process further, so that what was lacking technically in the synthetic product was able to be upgraded so that it wasn't lacking that anymore.
Right.
When I first came with the company, into the company,
Yeah,
At Target.
at Target,
yeah.
that was in the early 90s, and I was in the international customer service side. And
Yeah, let me, if you don't mind, I want to make sure people understand how you got into it.
Yeah.
So I wanted to try to create an opportunity to get the pardon me, the word out to the potential customers in the industry.
Mm.
And something, I didn't create, nobody that I knew of created it, but it was called telemarketing.
Mm.
And I said, we're going to start a telemarketing organization. And a couple of people in the company and Target at the time were a little bit nixed on that.
Yep.
I think it can help us get to a lot of customers. So I said, what we have to do is find the right people. Hence, you come in there.
Yep. Yep.
Rob Tait was one of them. 𝗟𝗏𝗄𝘃 was another, and 𝗘𝗶𝗺𝗪𝗃
Mm.
was another. They turned out to be the best marketing people that I've ever known,
Mm.
but they had to learn.
Yeah.
But they did a hell of a good job of learning,
Yeah.
and you were among them.
Yeah,
That's true.
And that was just one small piece of what you did to make Target the powerhouse that it became, in the industry.
Well, I don't deserve the credit for that, but it certainly took off. I think that's part of the offshoot of the business that you're in today.
Yeah.
So you started in the kind of telemarketing part of the business, but you eventually went into outside sales and started traveling.
I did. I was in outside sales for in the United States for Indiana and Kentucky, and did a few years of being a district manager, sales manager, and then eventually was brought back into the office and was the East Asia sales manager. And that's where we got into a lot of the larger grooving machines for highways and
And you
bridges.
did considerable amount of international travel.
Oh, the times he would come home just sick as a dog from
The travel would
from the travel.
once in a while would catch up to you. So
Yeah.
Yeah. You eventually evolved out of Target into your kind of next phase.
After running Target for a good number of years and traveling much of the world with Target and previously with GE, I decided to make an offer to buy Target from 𝗏𝗏𝗺𝗏. I met with the chief executive officer and the president, two different people of 𝗏𝗏𝗺𝗏, and convinced them that Target, being more or less a construction products business, didn't really have a place in the automotive products market.
Yeah.
And lo and behold, they agreed with me and said, okay, we'll sell it. What do you offer? We made an offer to buy Target from 𝗏𝗏𝗺𝗏. We thought it was a pretty decent offer. Unfortunately, one of the senior strategic development people that worked for 𝗏𝗏𝗺𝗏 went out, took our offer, and auctioned it off, and to the highest bidder. And that highest bidder happened to be Diamond Boart, otherwise known as Diamant Boart. That's French for diamond. Diamant is diamond, and Boart is the rough part of the diamond, uncut diamond. That's what Diamant Boart meant, and we Americanized the word and called it Diamond Boart. So we got outbid by $10 million for the company.
Wow.
The managing director of Diamant Boart, they just made an offer. They said, come over to Europe. So we did. We went over there, and my dear wife was back here taking care of grandbabies being born, and she gave me a choice. Either you want to be married or you don't want to be married. What's your choice?
Not
So,
much of a choice.
well, okay. Nobody ever explained it that way before. So I decided to come back, and I was the chairman of the board and CEO of Diamond Board Inc. here in the States.
And so how did Diamond Vantage come into the picture?
Eventually, Diamond Board, they wanted to downsize the company and sell it. They just kind of got tired of being in the construction products business. And finally, one day, one of the executive directors from the consortium in Belgium said, you know what, we're going to sell it. you may be too high powered for us.
Yeah.
In so many words. Those are my words.
Yeah.
Those are the words I like to hear, but that isn't quite what I heard. So I said, okay, adios, muchacha. It's time for me to leave. I decided I was going to retire. And I did the first time.
Yeah.
And then I got approached by a company by the name, the parent company, by the name of 𝗬𝗏. And 𝗬𝗏 wanted to start a construction products division or group. They needed somebody that could put them in the market. So I started a company called Diamond Vantage.
Mm-hmm.
And I gave them 2 years. I said, I'll come in, I'll do it, get it started, with some of my connections and other things. And from there on, I'll bid you farewell. Well, they came back to me near the end of 2 years and asked for 3 more. So I said, all right. I was having fun anyway.
Yeah.
So we did. I stuck around for a while, and then finally I just said, that's really enough.
Victory Machines came in there somewhere.
Oh yeah, well yeah. That was probably one of the things that General Tool had the biggest problem with. Selling only diamond tools very severely limits
Mm-hmm.
your access to the market, and I knew that. I started an adjunct to Diamond Vantage and introduced Victory Machines.
Mm-hmm.
And we manufactured a little bit of machines, very, very, very few.
So with all of those transformative eras that you've been through, what are you most proud of? What are some proud moments in your career?
Oh boy, the processes that we went through at GE,
Mm-hmm.
because it all started. The synthesis of diamond all started at GE.
Mm-hmm.
And well, not really, but they were the ones that perfected it. That was a whole evolution in itself.
Mm-hmm.
Things that were evolving that we had to, we had to make up.
Yeah.
They just didn't exist.
Yeah.
And
All
things like
front end cutting edge.
things like magnets.
Development. Yeah.
I used to, in my very early career at GE, I remember a couple times sitting at a desk in a lean-to shed. It wasn't even a desk; it was a counter, a workbench,
Mm-hmm.
in a lean-to shed. It had no insulation, even in the winter time. It was colder than hell in there too. And but I'd sit there with some of the vials of diamond like these, and would play with them with like a magnet and separating. And I found out, not my creation or invention, but it was a discovery in my brain. It was a discovery of that there are degrees of magnetism within the diamond. Well, lo and behold, maybe we can use that to help classify the diamond. So there's degrees that are needed for different applications.
Yeah.
They developed some what was called a Wilfley table. It was a shaker table which sat at an angle, and you pour the diamond on one end, and just by shaking it, it would separate the diamond by shape. The rounder diamonds roll down faster. The more square diamonds, they wander off to the side. Great technique.
Yeah.
We implemented it. By the way, just a little aside. One of the fun things with in my career, going back to you, was living through the legal combat between 𝗘𝗿𝗺𝗺 and GE. Because
you enjoyed that part?
Oh yeah,
just the challenge of it.
Just the knowledge of it. I was not directly involved in it. They were lawyers and very high paid, high tech engineers that were involved in it before I was ever at that level. But I had a lot of knowledge about it, but 𝗘𝗿𝗺𝗺's copied some of the GE processes. So GE decided, that's not fair. So we're going to sue you. So GE filed a patent infringement suit in South Africa. and we won.
That's a big deal.
That was big. That was huge.
Yeah.
And for a good number of years, till the patents eventually ran out, some of the patents eventually ran out, De Beers had to pay us royalties.
Mm-hmm.
And to pay us royalties, just ate at them. But also, on top of that, one of the little important factors in there, in order to verify they're paying the right royalty, we had to know their production and their sales numbers.
Mm-hmm. I'm sure
And they did not want to reveal those, but too bad. The courts ordered it.
If you had to look back on what are the things that you would tell young engineers and business professionals into the industry today?
Number of things. Be patient. Share the wealth, share the knowledge, share the experience with others around you. Don't try to hog it all yourself.
Absolutely.
Yeah.
You're being human, meaning that you got to remember other people feel and think and function just as you do.
Mm-hmm.
And you need to honor that and respect it. Machines don't talk back. They're a heck of a lot more fun to work with than people.
Yeah.
Yeah. People do challenge, but that also makes for success.
Our core values here at TSC came directly from, my time at Target and what I learned there and how to treat a customer and we definitely incorporate that into everything we do and I've taken that throughout my career.
Yeah.
Sharing, your success with your people and listening to them. That's definitely something that I learned as your daughter growing up with you as my father. I know that Rob learned that from you working with you many years ago, and we've carried that into our business today.
Yeah, we put the human values, at the core of our business, all the way from the customer service to our employees to everything we do here. We try to keep that human aspect in mind.
Well, we thank you so much for taking time to sit down with us, and we thank you for the legacy that you have created um, in the industry and on even a smaller scale with us. You've given us so much information and knowledge to work with to build this business, and we feel very fortunate.
Well, thank you very much. It's been an honor.
Yeah, yeah. Well, we will continue to carry your legacy on.
So tell me a little bit about this. I've had this like in a collection in my drawers for a while. And I know it was part of what you would carry with you, right? When you would travel?
Yeah, in the early days, later on in the business, we didn't really use these anymore, but this was in the early stages to show people what man-made diamond and other products were all about. So let's start with one of them right here.
Yeah.
It's called RVG, resinoid vitrified grinding. It's typically used in grinding wheels that are made either with a ceramic bond or a resinoid bond. This one is the same product called RVGW. The W stands for wet. Diamond doesn't like heat. And so if you're grinding with it, if you can cool it down, the diamond lasts longer. So we put nickel around the diamond crystal, and then you can use water with it. The nickel helps it hold into the matrix better. RVGD, the D stands for dry, and it's copper coated, exactly the same. All three are the same base product, all RVG. One is uncoated, one is nickel coated for wet, and the other is copper coated for dry. And because copper is a good conductor of heat, you can dry grind with it without hurting the diamond too much. The next one in this lineup is MBG, which stands for metal bond grinding, an acronym. And it's primarily for light sawing and grinding applications like glass, ceramic tile, and products of that nature, not for super hard things like granite or steel bar in concrete. This one here is the next evolution called MBS, which stands for metal bond saw. In the early 70s, we developed the next version of MBS, which we called MBS 70.
Gotcha.
And the 70 is no significance other than roughly the year in the early 70s. Then anytime you produce diamond, you always wind up with some junk, if you will. Well, that junk can be converted into something useful, which is called fines, F-I-N-E-S. And these happen to be ungraded fines. Sometimes you want the fine diamond to be protected from heat also, so you coat it. The developers of diamond said, well, maybe we can develop something stronger than diamond. Well, they started playing around and came up with boron and nitrogen, and it was boron nitride, which is trade named Borazon by GE. And it is not diamond. It is very hard, very tough, but not as tough or hard as diamond. But it will cut glass and so on and so forth.
So this last one?
And the last one is, this is also boron, but this is a coated one.
Okay.
Borazon, sorry, not boron, borazon.
Interesting. So that's a little kit that you would carry with you when you would go on
Show
your...
customers, because many times customers don't have any idea what a diamond even looks like. These things used to cost $5 a carat when we first started selling them. Actually, a little bit more, about 5.5. But anyway, $5 a carat. Today, this stuff is probably about 35 cents. But at the time when we were pricing these at our leisure, because we could, I can't even tell you what the margins were. It was simple. We printed money. Up in Buffalo, New York, they wanted to get into the diamond products. So one of the fellows up there contacted me one time and said, can you talk to me about this? And would you like to have our business? I said, sure, why not? Turned out to be $1 million worth of business in the first year, which wasn't too bad. I took some diamond up there in this jar, just like this, and it was probably about as I remember, about 3/4 full of MBG diamond, metal bond grinding diamond. And I said, diamond is very abrasive. It'll cut glass. Sometimes if it's in a glass tube or glass jar, it can break the glass by just the stresses. So GE, one of the GE's components, developed Lexan. So we started using Lexan bottles, which are unbreakable. And he said, what do you mean unbreakable? I said, they're unbreakable.
That's crazy.